is pressure. And this is exclusively for gaseous solutes. And the idea you can kind of show here. So what this graphic represents is the same amount of gas above a liquid. And this is at a low pressure. Now what happens is, on occasion, the gas molecules are moving randomly and they occasionally hit the surface of the liquid, and they may or may not become part of the solution. So what happens if you have the same amount of gas but you decrease the volume, you're increasing the pressure. But more importantly, pressure is also a measure of number density. And so you've got the same amount of molecules moving around in much less space, so they hit the surface of the liquid much more often, and more of them go in there. So the higher the pressure, so the solubility of the gas is directly proportional to the pressure of the gas above the liquid. If you increase the pressure of the gas, you're going to increase how much of the gas actually dissolves in there. And this is why sodas fizz when you open them up. So the effervescence, the tingly feeling, is because of carbon dioxide bubbles. So when you bottle your soda, it's actually bottled under a reasonably high pressure of carbon dioxide, which allows a relatively large amount of CO2 to actually dissolve in the liquid. Now, once you open it, you release the pressure and it has gone down from whatever to 1 atmosphere. All of a sudden, this solution has more carbon dioxide than it should at that pressure. So the carbon dioxide bubbles out, and this is the effervescence of it. All right. Now, since we have all the time in the world, because we don't actually have class period, I do want to point in one thing about the temperature effect of gas solubility. So, temperature. All right. So this, by the way, is a cooling tower for a now decommissioned nuclear power plant in Soweto, South Africa. But the mural on it was so awesome that I always just have to use it as an example. All right. So for oxygen at 25 degrees Celsius, the maximum achievable concentration you can get is about 2.7 times 10 to the negative fourth moles per liter. If you increase the temperature to 50 degrees Celsius, that temperature the solubility goes down to 1.7 times 10 to the minus fourth moles per liter. Why is this important? Aquatic life, fishes, fish, plants, require a concentration of about 1.6 times 10 to the negative fourth moles per liter of oxygen to survive. Now, most power plants, whether they are nuclear or coal or just about anything, require water. So usually something, either the uranium or the natural gas, creates heat. That heat is used to turn water into steam, and the steam turns a turbine and makes electricity. And then that steam needs to be cooled back down and recycled. So it was not just nuclear power plants that had these kind of cooling towers. That's also why they're often by large bodies of water, because you've got a supply of cool water. And so what happened is that in this process, originally people just didn't want to put near boiling water back into the river or the lake, so they would cool it down, sometimes to not much cooler than 50 degrees, which is still pretty warm. And they would find that there were still these dead zones where that water was discharged. And what it is that you superheat the water, you drive all of the oxygen out of it. And if all you do is cool the water, you still get deoxygenated water that won't support aquatic life. So what these towers did, and they're actually hollow, is they did two things. They cooled the water, and the water actually fell through the air from the top, and it would be collected down at the bottom. And that falling through the atmospheric air allowed it to pick up oxygen from the air. So it was a bit more, it was at least oxygenated enough to support aquatic life once you would put it back in the lake or the river. And so this process here it is called thermal pollution. So it's because it's because the solubility of gases, in this case oxygen, goes down with temperature, and this would make that that lake or that river, you know, unlivable for aquatic life if you didn't actively put the oxygen back in. All right, so that's it for this time, and we will see you next time.